Today in pre-cal we learned the concept of complex conjugates, which is the way to divide things that involve complex numbers. So part A, we did two different examples. The first one is 2 plus 3i over 4 minus 2i. You learned in Algebra 2 that if you have I in the bottom or a square root in the bottom of a fraction, it's not in proper or standard form. So to get it in standard form, you want to get the I out of the bottom. To do that, you're going to multiply by what's called the complex conjugate. To find that, you're going to take the bottom of the first part and do 4 minus 2i over 4 minus 2i. Just copy that and flip both of the signs. This piece right here is called the complex conjugate. Now, to solve that and get I out of the bottom, you're going to multiply straight across. You're going to FOIL the top and FOIL the bottom. 2 times 4 is 8. 2 times 2i is 4i. 3i times 4 is 12i. 3i times 2i is 6i squared. On the bottom, we have 4 times 4, which is 16, 4 times 2i, which is 8i, negative 2i times 4, which is negative I, 8i, and negative 2i times 2i, which is negative 4i squared. You should notice that on the bottom, my I terms cancel, and that will happen every single time. That's the point of getting rid of I on the bottom. If I combine my like terms on the top, I have 8 plus 16i. Combine these because they're like. And then 6i squared, remember the I squared is just negative 1, so that changes to negative 6. On the bottom, I have 16, and I would have minus 4 times I squared, which makes that positive 4. Okay, now on the top we can do 8 minus 6, which is 2, plus 16i, all over 20. And if I reduce my fractions using that that's a common denominator and split it into two pieces, I have 1 over 10 plus 4 over 5i. And that's in complex form now, in standard form. And so that's my final answer. Let's do another one like that. Example number 2. If I have 2 plus I over 2 minus I. A lot of people ask the question in class today, is a good question, why can't I just cancel the 2's and the i's because they're the same? And the answer is because the sign in between is not exactly the same, and because it's not one term that's being multiplied, I cannot cancel it. To get rid of I in the bottom, the only way to simplify is to use that complex conjugate. So again, I'm going to copy the bottom and flip the sign in between. I'm going to FOIL the top and FOIL the bottom. On the top, I'll have 4 plus 2i plus 2i plus I squared. On the bottom, I'll have 4 plus 2i minus 2i minus I squared. And I'm going quickly there, but that should make sense to you. You know plenty about FOILing, so that should be easy. The bottoms cancel. On the top, I have 4 plus 4i minus 1. That's what that I squared is. On the bottom, I have 4 minus I squared, so the minus I squared would be plus 1. On the top, I can combine 4 and negative 1 to make 3, plus 4i. On the bottom, I have 5. There's nothing to reduce, so as soon as I separate those two pieces out, I've got a good answer in standard form. So that's all that I have to do to get my complex conjugate, to get I out of the bottom and get a solution. The second thing we need to talk about is how to figure out what some complex solutions are. These are just some last key things that I want to mention to you before we move on from complex numbers. So, example number 3. If I want to simplify the square root of negative 3 times the square root of negative 12. This is different from anything we've done so far because the negative is under the square root. To get rid of that, I need to pull the negative out by taking out an I. So it's I square root of 3 times I square root of 12. I have to do that first, or I'm going to get an incorrect answer. Then when I multiply, I times I is I squared. Square root of 3 times square root of 12 is square root of 36. And if I simplify both pieces, I squared is negative 1. Square root of 36 is just 6. And negative 1 times 6 is negative 6. That's my final answer. The reason I put emphasis on taking the I out first is if I didn't, I'd do square root of negative 3 times square root of negative 12, which would give me the square root of positive 36, which is 6, not negative 6. So that's real important that you take the I out first and then multiply from there. If we wanted to look at one of those involving multiplication of a binomial, we could do negative 1 plus the square root of negative 3 squared. Remember from yesterday we talked a lot about how something's squared, you need to write it twice. And FOIL or box or distribute, whatever you want to call it. Again, we need to take the negative out of the square root first. So I've got I square root of 3 on both of those. And then I can FOIL that out. Negative 1 and negative 1 make 1. Negative 1 and square root of 3 is negative I square root of 3. I square root of 3 and negative 1 is negative I square root of 3. And I square root of 3 times I square root of 3 is positive I squared square root of 9. There's some things I can simplify here. Starting, I can leave the 1, and then negative I square root of 3 and negative I square root of 3 make negative 2I square root of 3. If that's confusing, think of adding together x and x. Those like terms just combine, they don't square when you add. If I have negative I squared, that makes it negative, and the square root of 9 is 3, so I can simplify that last piece. When I combine my like terms, I have negative 2 minus 2I square root of 3. And that is my final answer because that is in a plus bi form. The last thing we need to look at is how to use quadratic formula. We've done this before, but what to do if we're using the quadratic formula and there is a negative under the square root. So if you've forgotten that, it's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And if we want to solve that for 3x squared minus 2x plus 5 equals 0, we know that a is 3, b is negative 2, and c is 5. We're going to plug that into our formula. Negative negative 2 makes positive 2, plus or minus the square root of negative 2 squared, minus 4 times 3 times 5, all over 2 times 3. That's our a. If I begin to simplify that, I get 2 plus or minus the square root of 4 minus 60 over 6. 4 times 3 is 12, times 5 is 60, 2 squared is 4, 2 times 3 is 6. That's where all that's coming from. 2 plus or minus the square root of 56, and that's negative 56 over 6. I can take out that negative, so I have 2 plus or minus I square root of 56 over 6. 56 can be split up into the square root of 4 times the square root of 14, which is important to us because the square root of 4 is 2. And so I've got 2 plus or minus 2I square root of 14 all over 6. Let me back up here for a second. A lot of you probably thought 7 times 8 is the quickest multiple of 56, and you're correct, but because neither of those are a perfect square, that is not helpful information in this case, so you want to use 4 and 14. Finally, I can split this up because those are both reducible fractions, and I want it in complex form. So my answer would be 1/3 plus or minus I square root of 14 over 3, and that's my final answer. The homework assignment for this was A11. It's page 167, numbers 47 to 50, 59 to 60, 63 to 66. If you get stuck on any of those, 47 to 50 are like examples 1 and 2, 49 to 60 is like example 3, 63 and 64 are like example 4, and 65 and 66 are like example 5. Good luck, and let me know if you have questions.